The next thing in this section would be the general power rule. We've already talked about it a little bit, but this time we're expanding that general power rule to include things like radicals, negative exponents, and fractional exponents. So it gets a little bit tricky at this point of the section. So here's our first one. Yes, here's our first one. Okay, so the first thing I notice is that the x is in the bottom. So there's two different ways to work it. First of all, you could work this using the quotient rule we just studied. 9 would be your numerator, your high, and your low would be 5x squared, and you are welcome to work it that way. But there is an easier way to work it. Since you have a monomial term in the bottom, you can rewrite this. So rewriting it using algebra. Oops, let me fix that. Sorry about that. Now then. If you rewrite it using algebra, you can say that I have a 9/5 coefficient. Okay, so that's out front, we see that. But I can write that x in the top using negative exponents. So an x squared in the bottom would be an x to the -2 in the top. A negative exponent says you can move it across the division bar. Now that's the algebra part. Now we can actually use this function to do the calculus. So what my derivative rule tells me to do, my power rule, it says I keep the 9/5. Great. Now taking the power, I'm going to bring my -2 down. And then I have my x, and I decrease the power by 1. Watch your signs. So what this would give me is a -18/5 x. -2 minus 1 would be a -3. -18/5 x to the -3. Now when I make you do these for my quizzes, all of my answers should contain positive exponents only. So for my quiz, for my online class, this would be -18/5, and that x is going to come back to the bottom and be an x to the 3rd in the bottom. So a negative exponent in the top moves to the bottom. And that's what my answer would look like. For those of you in an online class and you're using the My Math Lab homework, sometimes it keeps it as a negative exponent and sometimes it changes it to a positive exponent by moving it across the division bar. So if you don't get the answer in the right form one way, just try it the other way. Okay, so let's try some more of these. Alright, so here on the board you see 3 more. Okay, the first one is already in its simplified form. So we can't simplify it anymore, but we can go ahead and take the derivative. So this would be the derivative of a fractional exponent. So what I'm going to do is bring the 5/2 down. I'm going to decrease this power by 1. So this would be 5/2 out in front, x to some power. Now at this point, you're going to need to be able to simplify, subtract 1 in your head. So 1 is just the same thing as 2 2s, or 2 2s, sorry. So 5/2 minus 2/2 would be 3/2. Okay, looking at our second one, it's not in the proper form. So we could use the quotient rule and go through all that low-d high stuff, or we could rewrite using algebra. To rewrite it using algebra, I'm going to bring my x to the top. Okay, now I can start my calculus. When the x comes to the top, the exponent becomes negative. So I have a 4. I'm going to bring the -2 down. I'm going to decrease the -2 by 1 because that's what the power rule says to do. So I would get -8 x to the -3. The -8's fine. There's nothing wrong with that. But you can't have a negative exponent. So the 3 must move to the bottom, and that would be -8 over x cubed. So then what happens if you have a radical? We rewrite using algebra. Okay, so the first thing I notice about this radical is it's a cubed root. We haven't done a cubed root yet in this course. So that means that the 3 is the denominator and the 2 would be in the top. So this 3 right here, the index is always the denominator, so that's what happened with that one. But that still doesn't make it where we can use the calculus because it's on the bottom. So I can rewrite it one more time and bring the x to the 2/3 to the top. Well, if I move across the division bar, I change the sign. So now that's my algebra step. I've rewritten it in a usable form, so now I can just take the derivative. I'm going to bring down a negative 2/3 exponent, and I'm going to decrease negative 2/3 by 1. So I get negative 2/3 on the front, and negative 2/3 minus 1 would be 3/3. So negative 2/3 minus 3/3 would be a negative 5/3. Okay, I can't have a negative exponent, so we'll clean it up. And x to the 5/3 would be on the bottom with the 3. And that's how it would look. Okay, so let's look at a couple more of these. Okay, on this next one, you have the f of x here. F of x equals 4x cubed plus 3x plus 1 all over 2x to the 5th. You are welcome to use the quotient rule. Low d high minus high d low over low squared. But you can also simplify using algebra. Either way works just fine. The algebra way is a little bit easier. So what I notice about this function is I have a monomial term. That means I could take 4x to the 3rd and put that over 2x to the 5th. And I could take 3x and put that over 2x to the 5th. And I could take 1 and put that over 2x to the 5th. Cleaning it up using algebra, I would get 2 over x squared plus 3 over 2x to the 4th plus 1 over 2x to the 5th. Now, I still can't use calculus yet because the x's are in the bottom. So if I rewrite it one more time, I'm going to get 2x to the negative 2 when I bring that up. This coefficient is just a 3/2, so I'll keep that in front. When the x comes up, it would be x to the negative 4th. And this would be a 1/2, that's that coefficient. When you bring the 5 up, it becomes a negative 5. Now then, all of that algebra. Now you finally get to start calculus. So now you can use your power rule. So when I bring this 2 down, 2 times negative 2 is a negative 4. Decrease this power by 1. So negative 2 minus 1 would give me a negative 3. Okay, my next coefficient is 3/2. I'm going to bring down a negative 4. If I decrease the negative 4 by 1, negative 4 minus 1 is negative 5. Looking at the next one, when I take this derivative, I bring down the 1/2. I bring down the negative 5. When I decrease negative 5 by 1, negative 5 minus 1 is a negative 6. So cleaning up this expression, I would get negative 4x to the negative 3. This would give me a negative 12 over 2, which would give me negative 6x to the negative 5. This would give me a negative 5/2 x to the negative 6. Finally, taking care of my negative exponents, this would be negative 4 over x cubed minus 6 over x to the 5th minus 5 over the 2 with the x to the 6th. And that's how that one would look. Okay, looking at this last one, I can't work it the way that it sits, so I need to bring the t up to the top. So that would be 6t to the negative 3. So my first step would be to rewrite using algebra, and that's how it would look. So working this one out, taking the derivative using the power rule, you would have 6t. For the second one, you'd have a negative 18t, and negative 3 minus 1 would be negative 4. So cleaning this one up, you would get 6t minus 18 over t to the 4th. And that's how it would look.